HTML. Let's have a look at some of these cases. We still got a server, and by the way, a server here also means that we probably have some database running on the server or running on another server, but being connected to this server. And now let's have a look at different that we can use it to transfer data around. Now, that sounds bigger than it maybe is. The general purpose of why we want to use it is that it's an alternative to a traditional web page for cases where the traditional web page just doesn't fit our needs. Now let's maybe have a closer look at this. So what is a RESTful API? Imagine we have a client, which is our browsers, we are the client, and we have some server, obviously, like a web page. There we send a request, for example, if we enter something into the URL bar, and we get back a response. And for a normal web page, as you know, that's a couple of HTML pages for the different URLs we enter. So we have a starting page, we have a products page, an order page, something like that. That is a traditional web page. Now if you're building a single page application, it's going to be a bit different. There you also send a request and you get back a response. But you really only have this step only once, because you get back one HTML page, which contains a bunch of JavaScript in the end, that will then dynamically re-render that page. But this is how web pages work. Now, that's great for traditional web apps, but what about some other cases where we also want to reach out to some server, but where we don't really need HTML? Let's have a look at some of these cases. We still got a server, and by the way, a server here also means that we probably have some database running on the server or running on another server, but being connected to this server. And now let's have a look at different clients. Maybe a mobile app running on our smartphone. And that mobile app obviously also needs to store and fetch data. The problem just is, it doesn't need HTML for that. The data is not transferred as a text file or something like this, or as a HTML file, I should say. Instead, we use some other data format and we really are just interested in that data. A similar case is if our client is some code, some application. Think of the Google geolocation API, where we can send coordinates and we get back a parsed address, for example. That also is a RESTful API, just to give a little spoiler here. And the idea here is that whilst we of course need to send data and get data, we're not interested in an HTML page. We just want to exchange data so that we can use it in our code. And finally, I already mentioned it, the single page application case. Here we actually have a web app, but only for the first request we need HTML. For all subsequent requests, we only want to exchange data, send some data to the server, fetch some data from it. And therefore here we also just need one HTML page and no more thereafter. You can build all of that with a traditional server-side setup, because a RESTful API in the end is also just a normal server. The big difference in the end is that we don't care about this HTML stuff, we just want to send data back and forth, and that RESTful APIs are stateless backends. They don't care about the individual client which connected to it. So if we have our client here, and we have our RESTful server, which is a normal server having some URLs it is able to accept requests on and so on, then we might have these endpoints. So these are the URLs supported by our servers. These URLs then each might also support different HTTP words. So we have GET and POST requests, but we might also be able to support a delete request, for example here to delete a user. Or the same for posts, maybe we have a patch request. That's also a HTTP word which exists. Or for products, maybe just a GET request. So this is how a RESTful API could look like. We have a couple of URLs, and each URL then possibly has a couple of different HTTP words, and therefore types of requests it supports. And then from our client, we can send a request. If we're having a web app, we would call this an AJAX request, asynchronous HTTP request. One where we don't send a request and get back a new page, but one where we send a request, our current page keeps on running, and eventually we get back a response, which we then, if we're talking about a web application, typically handle with JavaScript to re-render the DOM or do whatever we need to do with that response. And if we have some other kind of application, like a mobile app, then we still would have some tools provided by Java or Swift, whatever it is, whatever you use for writing that app, that would be able to send a request and handle a response you get back. This is the idea behind a RESTful API. We have a server with URLs supporting different types of HTTP requests for the given URLs, but all we do is we exchange data. Now, if we have a look at this setup here, this data is typically exchanged in JSON format. It's not a must though. You can send XML data, URL encoded data, like where you have like query parameter style, form data. You're not limited to JSON. I'd say the one thing you typically always have is you're not sending HTML around. Though theoretically you could also do that and parse it, but not with the goal of rendering it through the browser, because these API endpoints here are not going to get targeted directly by the browser in a sense of the user entering any of these URLs. That's not going to happen. All these URLs are going to be targeted by background requests, like a XML HTTP, a AJAX request sent from JavaScript, or the equivalent for a mobile app. This is how we use it, and we use it to exchange data, because that is essentially the only way we can connect a single page application or a mobile app to some backend. They don't want HTML, they want the data, they want to send data to. So this is the idea behind a RESTful API. Now, if we go into theory land here, then this is not necessarily a RESTful API. A RESTful API is a clearly defined construct, and just having a couple of URLs with different supported HTTP endpoints is theoretically just a backend and an API you created. We often call all these APIs RESTful though, because it's the word or the expression for a backend that is not a traditional server sending back HTML, but data. But theoretically, we got a couple of constraints that really turn an API into a RESTful API. We have 6 such constraints where one is optional. I know this is really theoretical. We're also going to build one in this series so that it's a bit easier to grasp, I guess. So the first constraint is a client-server architecture. If we're building a RESTful API, then we have a clear separation of concerns between our backend, which is there to manage data, do calculations, and send us back data, and our front end, which could be a single page application or a mobile app, which is responsible for the UI. Our RESTful API also is stateless, so we don't store any client context like a session on it. That's super important. A RESTful API doesn't care about the clients connecting to it. It doesn't care if it's reached by a single page application and a mobile app and maybe some other application. It doesn't store anything which clearly binds it to one of these applications, like a session. It's not handling sessions, it's not caring about sessions. And this is going to become important when we add authentication. We have cacheability in a sense that a RESTful API typically should also, well, express itself or tell the client whether responses can be cached or not. And this is also kind of the case if you don't explicitly set it up, then there's just some default going to get used, but you can't clearly define if, for example, for a GET request, you want to cache the response, you want to allow the browser to cache the response, and for how long that should be the case, or if you would absolutely want to forbid any caching because you know that your data changes so frequently that caching doesn't make sense. So you can set up caching responses here too to really make sure that the client is using the API in an efficient way, and this is just something you can do in a sense of you can clearly tell that caching should be enabled, for example. We also can build our RESTful API in some layered system, which means the client connects to some server, but that server doesn't necessarily have to be our final API. It could be some in-between server which forwards the requests or which sends back a response, but behind the scenes also reaches out to our API. And as I said, we're really in theory land here, but we just don't have the guarantee that our RESTful API, we don't give the guarantee, I should say, that our RESTful API we also have a uniform interface, which means that resources are identified in the request. So we send a request to, let's say, /users, and we send a GET request that clearly identifies one resource, the user's GET resource, and that the data transfer can be decoupled from the database. So if we store a user in a certain way in the server-side database, we don't necessarily have to transfer it like this to the user. We can deviate from that schema. Also, it's good if we have self-descriptive messages and links to further resources. For example, if we send a request to GET users, we would probably get back a list of all the users, and then it would be really good if for each user object we don't just get, let's say, the ID, but we also get a link to which we would have to send a subsequent request to get the data for that user, so that we don't have to guess about the API endpoint we would send a request to. Because that is something crucial to keep in mind, of course. When you're building an API, you only have these addresses, you only have these URLs, and if you're not aware of them, if you have no documentation to look it up, and if the API doesn't send information about other addresses back in responses, then you have no chance of using that API, because how would you know to where you send a request? If you compare it to a web application, a traditional what I mean, where you have multiple HTML pages, there the user would navigate around with links. So there we also have that information about other pages we can visit. And it's kind of the same here for the RESTful API. It's good if we provide this information back to our clients. That means that theoretically we allow still be a RESTful API if we implement it such that it gives the client back some executable code. And that's not something we're going to build here. It really just means it doesn't have to be just data. It could also be some code that the client can execute rather than just data for that code. And again, these constraints are all just theory constructs. So these are really just, that's the theoretical definition of a RESTful API. We're going to build one here, and we're going to build one that works and that makes sense. So don't learn that by one. So you need to know all of that. Be aware of the state of things here. The clear separation between client and server. That seems to be the most important things to me, because that's something which often is hard to grasp, and you often get asked, well, how can your Angular single-page application, how can I create a session on the server? And the answer is, you can't really do that, because in a single-page application, you use a RESTful API because you only need the data, and a RESTful API shouldn't really care about the client connected to it, shouldn't really manage sessions, because you never reload pages anyways. So that's important to know. You're independent from the client, you're stateless. Now, enough of the theory, let's build a RESTful API in the next video. Welcome back to this series where we built a RESTful API with Node.js. In the last video we had a look at all the theory, and that was important, but now let's dive into the fun stuff, and let's start building a RESTful API. So let's have a look at what we'll build, and then let's start with it. So what are we going to build in this series? Our API will have a couple of resources. I want to build an API that's realistic and that contains some things which are typical to RESTful APIs. For this, we'll have a products resource, so /products is one route we can target. And there I want to support GET requests to get a list of all the products we have, POST requests to add new products. I also want to be able to target an individual product by ID and get information about that product, add that product, change it, update it, delete this product so that we can get rid of it. And let's also implement an orders resource where we can place orders. So where we, for example, could get a list of all the orders we have. I also want to be able to post a new order, so create a new order. And I also want to be able to then access my individual order and just like for products, get more information about it and not catch it. Let's say we shouldn't be able to edit our orders, but we could delete, so cancel them. That is what I want to build. We'll also to make sure that some of these routes, of these endpoints, are protected, so that only logged in users can access them. And therefore you will also learn how to log users in when building RESTful API, because we can't use sessions, remember, from the last videos, so that won't work. We're going to build it step by step. We're going to start with it right now. Let's start with building this RESTful API. And for that, I'll navigate where I navigated already and you can of course also use the Windows Explorer or the Finder. You don't need to do that in your terminal. I'll name it Node REST Shop, something like that. Then with cd Node REST Shop, I can navigate into it, and now we have an empty folder. Now we first of all need to put this under control of that. You can assign a package name, version, some description like a Node.js RESTful API tutorial project, build a simple shop API, something like that. Endpoint doesn't really matter for us here. Test command, I'll leave that in. You can enter a Git repository, I won't do that for now. You can enter some keywords, don't need to, and offer, you know, put mine in. Just created in this editor, and there you see this package.json file that was created automatically through this npm init command, and here you can always tweak these things you just confirmed in the terminal if you want to. Now open the terminal in this editor. That's the built-in terminal into Visual Studio Code. It's the same as the default terminal on the operating system though. And I now want to install a couple of dependencies we'll need. We need Node.js. I will install this is Express. Because I will use Express and Node.js to make building this API a bit easier. And we'll add more